Okay, first things first, I just want to point out, in your email you wrote to me where you typed out your equations, you actually had this one written out correctly. You said this was 700 right here, but then on your paper I'm seeing 800. It should be 700, because it says you want to save no more than $700. So I'm not quite sure where the 800 came from. Maybe it was just a typo, or a righto, whatever you want to call it. So then that equation is now correct. Then the other equations are now correct. Everything is good if you just make that a 700. So now sketching our graph. Oh, and your cost equation, perfect. Everything looks good. You're good there. So now sketching our graphs. First things first. I'm going to go intercept method with this. So I'm going to say when I put in 0 for x, what do I get for y? And when I put in 0 for y, what do I get for x? In relationship to this first equation. So 700 divided by 2, well, that's 350. And then when I put in 0 for y, I apologize, I just did that backwards. When I put in 0 for x, I'm dividing by 0.2. So 700 divided by 0.2 is 3,500. There we go. And then when I put in 0 for y, that's 700 divided by 2, so that would be 350. So when I'm sketching this graph, that's the equivalent of this line right here that you've got going. But I know my intercept should be at 350 and 3,500. So I'm going to go ahead here and just kind of sketch out a new quick graph just like you're doing. Forgot my numbers though. Let's go back and look. 0, 3,500. So, and it's not terribly important. You are super accurate. You just have to be close enough to see what's intersecting where. So it was 0, 3,500, and then the other one was 350, 0. Okay, so in 350, my goodness, it is late. Okay, 350, 0. Okay, so that equation, connect the dots from there to there. There we are. Now, how are we going to shade this? Well, let's go to our test point. So when I substitute in 0, 0, 0 plus 0 is less than or equal to 700. That is true. So therefore, I must be shading down. I'm shading in. Okay, so now let's graph our next line. Our next line here is x has to be less than or equal to 200. Alright, so we just go over here to 200 and say, where is 200? Well, it's somewhere inside of 350. It's a vertical line because it's x equals. There we go. Make sure you do the sound effects. Now, less than or equal to. So if I want something less than 200, then that means it's going to be going to the left. So shading this direction. Alright, now for the next equation. That one is right here. Y is less than or equal to 2,900 because that was the amount of wall space we had. Once again, that is inside the 3,500, so it's going to be somewhere up here. 2,900. That's going across this direction. And since we want less than, that means we have to be going down. So we're shading down. And I think that's all of our constraints, other than the real-world constraints that x has to be greater than or equal to 0, y has to be greater than or equal to 0. So our corner points now are all going to be in this shaded region where everything agrees, where everything is shading towards. So the green shading in, black shading in, red shading in. So we're trapped in here somewhere. Okay, so now the question is what are the corner points in this region? So we have corner point A, B, C, D, and E. Now, A is silly because A is just 0, 0. We don't need to worry about that point. We already know if our goal is to maximize, doing nothing is not going to maximize our costs. It's not going to happen. So B is pretty easy. We already know that point. That was 0, 3,500. C we need to figure out. But notice that's the intersection of, well, we know the y value. The y value is 2,900. So we now just need to see for our one line that was diagonal, for the one line that had the first equation, when we put in 2,900 for y, what do we get out for x? Once we do that, that'll give us that corner point. So I go back up to the equation and So 2x plus 0.2 times 2,900 should be less than or equal to, but we're just trying to solve for x, so we can just make it equal to 700. So now when you solve this, you end up getting 60. So I go back down now. Okay, so I know this corner point is going to be 60, 2,900. D, very similar, except now we know the x value is 200, so we go back up to the original equation, substitute in 200, figure out what y is. I'll let you do that. When I did it, I got 1,500. So then we have our last corner point, E, which again, this is another relatively easy one because we already know it. It's 200, 0. Now, using some logic, we know our goal is to maximize cost, and our cost equation was, you already figured that one out, cost was 4x plus y. 4x plus y. So, obviously, putting in 0, 0, it's going to give us a cost of 0. That's not going to be our answer. Now, putting in 0 for x and 3,500 for y, well, that's easy math to do, because this one's going to result in a cost of 4 times 0 plus 3,500, so therefore it's just 3,500. All right, so we got that one. That corner point's done. Now, this one, the cost here, now this one's going to be a little more fun, because you actually have to do 4 times 60 plus 2,900. And the question is that going to be greater than 3,500? And using a little bit of common sense, you can already say, no, it's not. But it comes out to be 3,140. So if we're trying to maximize, we can toss out C. It came out less than 3,500. So far, that point's our winner. So here we go, on to the next one. When we substitute in for here, we're going to have 4 times 200 plus 1,500. Well, little quick math. 2 times 4 is 8, 800. So 800 plus 15, not more than 3,500. That's not going to be the answer. And then clearly, if D wasn't the answer, just changing this to 0, that's not going to be the answer either. So therefore, we know our answer has to be B. So we know we're going to have a maximum cost of $3,500 when we replace 0 light bulbs and 3,500 square. Excuse me, did something go awry? Oh my goodness. Well, it helps if you can actually read your shaded region. So let's try that again. Our B point doesn't go up to 3,500, it goes up to 2,900. So fix that, 2,900. So now this is just going to be 2,900. So let's go back here and look. Go away. Okay, so good thing I left all this on the screen still. So corner point A, that was still a cost of 0, so that throw that one out. This one's 2,900. This one was 3,140. There we go. So that's now our winner. That one's doing pretty well. And again, we can double check this, but 4 times 200, that's 800 plus 1,500, so that's just 2,300. So that's less than 3,140. So that's not it. This is going to be less than that. So there we go. So now there's our answer. Our answer is at C. Much, much better. I apologize for that. So our answer is C. We're going to have a max of $3,140 when we replace. That is the worst spelling of when. Man, it's getting late. Okay, when we replace 60 bulbs and insulate 2,900 square feet of wall, or cubic feet of wall, however they're measuring square feet. So 2,900 square feet. So there's your answer. So if you go back now, we can double check that. We'll go back to the actual problem itself. Yeah, and so you'll see 60 compact fluorescents, 2,900 square feet, total cost of 3,140, with a energy savings cost of, well, you can put that back in the energy savings and see it's $700. Okay, I hope that helped. I apologize for the mistake.